Okay, let's look at a harder chain rule problem where we have to differentiate y equals ln of a reciprocal of x squared minus 4x minus 12, and then we have to evaluate that derivative at x equals 1. So to start off, we're just going to power through this the hard way so you can appreciate a shortcut I'll show you at the conclusion of this video. So let's differentiate. So we have to recognize we definitely have a composite function. We have some trapped business inside our natural log. So remember, when you're differentiating a natural log, you have to take the reciprocal of the input of the natural log. So this is a confusing way to write it, but I have to take the reciprocal of 1 over x squared minus 4x minus 12, which of course will just become x squared minus 4x minus 12 in the next step. Okay, so we're not finished. I dealt with the reciprocal of the outer function ln, so now I have to multiply by the derivative of the inside function, which of course is a reciprocal of a quadratic. So this reciprocal inside here is causing, I guess, lots of misery, at least in this approach. So there's step 1. So now let's clean this up. That's kind of an insane way of writing that. That's just x squared minus 4x minus 12. Treat it as one thing in this product. And then think about how we can differentiate this. Of course, the quotient rule is an option, but it might make more sense in a separate step here, which I should have maybe done before, is recognize that this is the same thing. If I say that to the power of -1, and then of course we can use our power rule to differentiate that, but also chain rule because we have a trapped quadratic there. So let's keep going. We got x squared minus 4x minus 12, which we're finished with. Just have to rewrite it. And now we can do our power rule, followed by, of course, application of the chain rule here. So -1 comes down in front. So I'm differentiating the -1 power first. And then I have to multiply by the derivative of the inside quadratic, which I will try to squeeze in here. Lots of space. The derivative of x squared minus 4x minus 12. So this is spiraling out of control, but we're almost finished. So this is going to be x squared minus 4x minus 12. And I think I might start to move some stuff around here. Now remember, this is going to be all over. I have a negative exponent, power of -2, and that comes down to the bottom. It's going to go to a +2. Okay, and don't forget that negative. I'm actually cautioning myself as much as you. The derivative of this we can probably just do in our head is 2x minus 4. So I have a negative in front of a 2x minus 4 here, which probably make more sense just to multiply this through our last rewrite of this. Okay, so we can cancel off this top quadratic with one of those two quadratics multiplied or squared in the bottom, and we have our derivative. And keep in mind, this was the hard way. I'm sure you can agree that that wasn't so elegant. So that is gone. The next step with that square, and let's multiply that through to get minus 2x plus 4, or we could say 4 minus 2x all over x squared minus 4x minus 12. And I'll hold off on evaluating this, but of course we do have to evaluate that at +1, I believe. So let's do our alternate differentiation here first, because that was pretty miserable. I'm sure you can agree. Okay, so here we go again, and of course to make this a lot easier is dealing with that reciprocal right up front. So let's do this in green. It's a little hint to say this is how we should have differentiated this before, but of course you wouldn't have known what you were missing, and you can rewatch the video if you enjoyed that for some reason. Let's realize that I can write this as the natural log of x squared minus 4x minus 12 to the power of -1. And then we can utilize a log property. That power can come down in front. And we've gotten that dealt with. I guess I can just say that that's a ln. Now we don't have to say -1. So that's a minus ln multiplied by x squared minus 4x minus 12. So now we've got a negative to sidestep, but we don't have to differentiate a reciprocal function, and this is going to be a lot smoother when we differentiate this. So sidestep the negative, and then differentiate the outer function, which remember is the reciprocal of the input inside that logarithm. So I'm differentiating the logarithm. So we have an x squared minus 4x minus 12 now on the bottom, and then the chain rule is really what we're applying here. Multiply that by the derivative of that trapped quadratic, which of course is x squared minus 4x minus 12. So we're almost done. We have that rogue negative here on the top, and the derivative of this of course is going to be 2x minus 4, since that's just ooh, we're getting a little crazy here. There. So that was 2x. My tablet's sliding around on me. 2x minus 4 is that derivative. Don't forget the negative, and of course that's all over x squared minus 4x minus 12. So now we just have to multiply that negative through, and that's really a two-step question, which is a lot easier than the mess that we had above. And then we have to finish this off by, of course, evaluating this function as well. So let's do one more rewrite. Tread lightly, I guess, or carefully with that negative. This will be 4 minus 2x all over that quadratic, x squared minus 4x minus 12, and then we can evaluate that at x equals 1 as asked. So of course that's going to give us 4 minus 2 times 1, or 2 on the top, and then on the bottom we'll have 1 minus 4 minus 12, which is negative 15. So of course we should write that as negative 2/15. And remember, that is actually our tangent slope at x equals 1 for this function.